We are going to learn about osmosis today. It is a very important concept in biology. Osmosis is essential to the survival of organisms and has many daily life applications, such as pickled foods. The process of making pickled foods involves soaking the foods in a solution with high salt or sugar concentration. By osmosis, water is removed from the food and the microorganisms present in the food. With less water present, the growth of microorganisms is inhibited and the food can be preserved for a long time. You have learnt about diffusion in the previous section. It is the net movement of particles from a region of higher concentration to a region of lower concentration, and this process does not require energy input. Osmosis can be considered as a specific type of diffusion. It is the net movement of water molecules across a differentially permeable membrane. In this case, water molecules lead the role, and we will focus on their net movement. First, let us take a close look at the experimental setup shown on the screen. Note that there are two types of sucrose solution in the container. The one on side A is a concentrated sucrose solution. The one on side B is a dilute sucrose solution. The two solutions are separated from each other by a differentially permeable membrane. A differentially permeable membrane has numerous tiny pores, and these tiny pores allow small particles, for example water molecules, to pass through, but not large particles, for example sucrose molecules. Bear in mind that water molecules can move across the membrane in both directions, from side A to side B, and from side B to side A. As we can see from the diagram, side B has a larger proportion of water molecules than side A because it is more dilute. Therefore, more water molecules move from side B to side A. In other words, there is a net movement of water molecules from the dilute solution in side B to the concentrated solution in side A. Do you know what would happen if you leave the setup for a period of time? After some time, the solution level on side B falls, while it rises on side A. Same as diffusion, osmosis occurs passively and requires no energy input. For more details on the basic concepts of osmosis, please refer to page 14 of Chapter 4 in Book 1. You should now be able to finish the questions in Activity 4.1 by yourself. Before we try to use the concept of water potential to explain osmosis in the next video.